Hi, my name is Barbara Sevilla, and for this presentation, I will go over the development of the Atkinson cycle engine. I chose my project about the development of the Atkinson cycle engine because of the eye-opening cause and effect of the emissions coming mainly from the vehicles today. This project could make a big impact not only in the field of research and development, but also in the society's environment to develop an alternative source for the engines used today. This research have supporting theoretical and actual performances comparing the difference of a conventional Otto cycle engine and Atkinson cycle engine, which have shown significant impact on reducing emissions. Just a little bit of an overview of the main topics I'll be covering in this presentation is first the background of how Atkinson cycle engine started. Next is the framework design involving how the cycle of this engine works compared to an Otto cycle. I will also cover the advantages of the Atkinson cycle, mainly focus on its efficiency and environmental impacts, and lastly conclude the presentation. Just a little bit of background of how the Atkinson cycle engine started. In 1882, James Atkinson invented the very first Atkinson cycle engine. The reason for this is to support reducing the greenhouse gases and harmful emissions. Some examples include nitrogen oxides, hydrogen carbon, and CO2 from the transport sector, especially from vehicles. Researchers have found that approximately 22% of CO2 emissions are caused by vehicles in Europe and about 85% in China. The Atkinson cycle engine was designed to improve the energy efficiency and to serve as an alternative for current engines. In this slide, we will look at the comparison between Atkinson cycle and Otto cycle. This figure shows the theoretical PV diagram representation of an ideal Atkinson cycle engine and a conventional Otto cycle engine. Both cycles start from 6 intake stroke to 1 exhaust stroke to 2 compression stroke to 3 constant volume process. The difference between these cycles comes in the power stroke process in the figure. Otto cycles power stroke seen in 4 to 5 intake valve timing, while Atkinson cycle, as shown, uses more volume in 4 to 5 of the isobaric process. Some advantages of the Atkinson cycle engine are fuel economy, which will be shown in the next coming slides. Reduction of emission. Examples will be mainly focused on the CO2 emissions in the next coming slides as well. And lastly, vehicle drivability. Increasing the fuel economy and lowering emissions, the Atkinson cycle engine will enhance the vehicle by also helping the environment. The efficiency of the Atkinson cycle engine has been tested by applying the new European Driving Cycle, or NEDC, Federal Urban Driving Schedule, or FUDS, and Federal Highway Driving Schedule, or FHDS. At loads of 8 Newton meter, 10 Newton meter, 12 Newton meter, and 14 Newton meter, during the standard NEDC, the fuel consumption comparison between the variable compression ratio Atkinson cycle engine and the conventional Otto cycle engine at various engine operating conditions are accomplished. The difference between the fuel economy of a higher load of 14 Newton meter and a part load of 8 Newton meter is that the higher load is 2.02% and the part load is about 10.87%. The average improvement in the thermal efficiency is around 3.57%, while the improvement between the variable compression ratio Atkinson cycle engine and a conventional Otto cycle engine at medium and higher engine operating conditions is about 6.22% during constant NEDC. On the other hand, the comparison between the said cycle engines under a similar engine operating conditions during the standard FUDS and FHDS driving cycles are demonstrated accordingly in the figures of FUDS and FHDS. For the efficiency, we will look at Toyota Camry and Toyota Prius. First is the Toyota Camry hybrid type, which has a fuel economy of 51 miles per gallon in the city and 53 miles per gallon in the highway. Next is the Toyota Camry gasoline type, which has a fuel economy of 29 miles per gallon in the city and 41 miles per gallon in the highway. Lastly is the Toyota Prius Atkinson cycle type, which has a fuel economy of 54 miles per gallon in the city and 50 miles per gallon in the highway. With the given numbers, it is clear that it shows that the Atkinson cycle is better in the city than the hybrid due to its low RPM efficiency, is when the Atkinson cycle is utilizing its maximum torque or power. Just to show a little bit of background of how engines today has an impact on the environment. Researchers have calculated of about 50 years before the total global petroleum reserves will be consumed. This is with the assumption of daily production remains steady at 63.5 million barrels. This is the main reason why Atkinson cycle engine has been developed as an effective alternative source in the hope of prolonging the reserves of the petroleum. For the environmental impacts, we will look at Honda Civic and Honda Insight. First is a Honda Insight utilizing an Atkinson cycle engine with CO2 emissions of 101 grams per kilometer. Next is Honda Civic with CO2 emissions of 110 grams per kilometer. Lastly, we have the Honda Civic hybrid type with CO2 emissions of 109 grams per kilometer. Even though the Honda Insight's engine setup is similar to the Honda Civic hybrid's engine setup, both being hybrids, the CO2 emissions using the Atkinson cycle setup was able to improve by almost 10%. This presentation about the development of the Atkinson cycle engine has demonstrated performance that is a better alternative for a conventional Otto cycle engine. The PV diagram has illustrated how Atkinson cycle fully utilizes the power stroke of the system for a higher specific volume. The driving cycles have proven that the Atkinson cycle demonstrated lower fuel consumption than the Otto cycle given 3-part load trials. The Atkinson cycle engine has proven to reduce the CO2 emissions in supporting the environment for an alternative energy source. The relevance of this topic to energy conversion is how two similarly hybrid engines, with one utilizing the Atkinson cycle and the other one uses the Otto cycle, can dictate the efficiency in fuel economy and as well as the amount of the CO2 emissions produced by the engine. Being more fuel efficient, the Atkinson cycle engine more efficiently converts fuel to usable energy while producing less CO2 emissions.